let's see, a dear friend, uh, module 10, which is the last one, right?
10.
So,
Yeah, with module 10, does a QA team still load test an application, or is this? It seems like it does it makes sure your application is going to work well in production.
I don't know what you mean.
Okay, that's fine.
Guys, are you taking the labs? Are you taking the labs?
Yes, but I'm not done with all of them yet, but I'm almost.
I've not ended labs. I've been trying to focus on finishing it, get prepared for the exam.
Yeah,
After the exam is done, I'll do the labs.
Yeah, I'm the same. I'm really trying to get through the exam.
But I will do the labs.
Yeah.
For sure, because they're important.
Yes.
There are a couple of things we need to practice.
Yeah. Don't take too long because I don't know when they want to close the class, right? They have a set date, which I'm not sure.
Right? Yeah, there is is it Google Classroom that's set up with AWS?
No, that's me.
It's AWS Academy that has a lab.
Correct.
Yeah, because there's if you don't mind, I can share something real quick.
Go ahead. Share the screen, please.
This is what I've been using. AWS Academy. Yes, you're right. So it has in as well lectures, and the modules having like the labs.
Correct.
Is this what you're referring to when you say we're doing the labs?
Yes.
Yes, and the knowledge check too.
Yes, and the knowledge check. One more quick question, Mr. Otano. I honestly do not remember what email I used to sign up for this.
What email? Maybe you can look at the account. Click on the account section, and see settings. Maybe settings. Student login. Why? You have to be logged in, right? Okay. Is there any way you can see your profile somewhere? I don't think that you can see the announcements. I mean, you can. Okay. Go back to account.
So I have not logged out of it since I've started. Because I don't know if anybody else has tried. Does anybody else have a MDC email that works?
Okay, I'm gonna tell you. Let me. I have that information. Just give me 1 second.
The only way I knew which account it was is that I sent a request reset password. So I just looked between both accounts and which one it was. So when I finally got it, it turns out it was like my normal Gmail. That's the only way I knew it was. Right now I'm looking. I don't see any other way to see which Gmail.
Yeah. Because honestly, I've been afraid to log out of this. I don't even close this window because it has the videos, the student guide, the labs, the knowledge check, all that is right here. So I've been going through these to augment what we've been doing on a Saturday. But I don't know what email I provided for this. So I have not logged out of it.
Yeah. Sean, right?
Actually,
Sean,
in the settings, it says which one.
Okay. The email you use is GEA283@gmail.com.
No, that's Dave. That's mine. That's Damien.
That's John. This is Damien, Mr. Otano.
I'm sorry. Damien is Damien.bigb@gmail.com.
Excellent.
And I believe you can also look at it in the settings, by the way.
There's still students that never accepted the Canvas.
It doesn't let you until you
sign in again. 10 weeks have passed, and there are people who haven't accepted the Canvas invitation. That's amazing. Okay. So let us start. Let's start the class.
This is number 10.
Yeah, number 10.
All right.
Okay. So let me share the screen. All right. So the module is going to be automatic scaling and monitoring, right? And topics: Elastic Load Balancing, Amazon CloudWatch, Amazon EC2 Auto Scaling. Activities: Elastic Load Balancing activity, Amazon CloudWatch activity. There's a lab, scale, and load balance your architecture. And there's a knowledge check for this guy. Module: after completing this module, you should be able to indicate how to distribute traffic across Amazon Elastic Compute Cloud, EC2, instances by using Elastic Load Balancing. Identify how.
Excuse me, Professor, sorry. Can you mute? I think Sandra's microphone is sending static from my side. I can hear echoes. Thank you.
I did already. So identify how Amazon CloudWatch enables you to monitor AWS resources and applications in real time. Explain how Amazon EC2 autoscaling launches and releases servers in response to workload changes, and perform scaling and load balancing tasks to improve an architecture. Okay. So let's talk about Elastic Load Balancing first. All right. So what does it do? It just distributes incoming application a network traffic across multiple targets in a single availability zone or across multiple availability zones. Right? So it scales your load balancer as traffic to your application changes over time. Okay. So you have several users here. You have the Elastic Load Balancer, which is going to distribute the traffic, the incoming traffic to different resources here. It could be a simple an EC2 instance, it could be a container, it could be a Lambda, right? Or it could be IP addresses, it's depending on whatever you're moving the traffic to, okay? So in modern high traffic websites, they have to serve hundreds of thousands, if not millions, of concurrent requests from users or clients, and then return the correct text, images, videos, or application data in a fast and reliable manner. So additional servers are generally required to meet these high volumes. So Elastic Load Balancing is an AWS service that distributes incoming traffic, like it says here. Right? And it would do it across multiple targets. The targets can be EC2 instances, the targets can be containers, IP addresses, Lambda functions. And all of this could be in a single availability zone, or it could be in multiple availability zones. So you have to enable cross-zone load balancing. Right? Now, Elastic Load Balancing scales your load balancer as traffic to your application changes over time. Right? It will work in conjunction with autoscaling. Right? Now, there are three types of load balancers, right? Mainly three types. There's a new one now, but it is not in the scope of this exam, right? We have the application load balancer, right? The network load balancer and the classic load balancer, which is the previous generation one. Still used, still included in the Elastic Load Balancer wizard when you create the Elastic Load Balancers. Okay, so what does the application load balancer do is just balances the load of HTTP and HTTPS traffic requests. It will work in the layer 7 of the OSI, the open systems interconnection model. Okay, if you take a look at that guy, we still say OSI model, right? We can have some images here. This is one that I always use, right? It's an image that contains all the layers of the OSI model: the application, the presentation, the session, the transport, the network, the data link, the physical. Every computer has these layers, right? Of course, the computer doesn't have layer. I mean, the layer like is physical something. No, it's just that it's just a representation. It's a model where the protocols and the appliances are. Okay, where you can find the appliances. So the computer has connection with all of these guys. So you have, for example, you can have a hub or a repeater, and that is connected to a computer, right? Or you can have a switch or a bridge, and that's connected to a computer. But these guys, they belong to the data link layer, okay? And these guys just belong to the physical layer. So your computer is going to be connected with all this, right? The transport protocols, TCP and UDP. They're connected to a computer, right? Transmission control protocol and user diagram protocol. So those are things for networking, and they can be found in the transport. Now the application, this is the one that has to do with the application load balancer. You can find HTTP and HTTPS. You can find SSH. You can find FTP, file transfer protocol. You can find DNS, domain names service or system. This is where the application load balancer works in the layer 7 of the OSI model. 1, 2, 3, 4, 5, 6, 7 here. Okay, this is where the load balancer works. Now, the network load balancer will work at the transport layer, which is the layer 4. You have here the transport layer 1, 2, 3, 4. That's the transport layer where you can find the network load balancer with the protocols for transport. Okay. Then this guy routes the traffic to targets based on content of request. The targets are the EC2 instances or the Lambda functions or the containers, whatever you're using as a target. It provides advanced request routing targeted at the delivery of the modern application architectures, including microservices and containers. Remember, microservices, just little services where you can decouple the elements of your application into services, okay? And then you can make sure that your application is more resilient when you have microservices, right? In the case of network load balancer, if we route the traffic to targets, EC2 instances, containers, IP addresses, or Lambda functions based on IP protocol data, okay? It can handle millions of requests per second while maintaining ultra-low latencies. And it's optimized to handle sudden and volatile traffic patterns. So guys, don't forget this. I mean, try to take a look at it today when we're done with the course. Take a look at it, because from here, you can have a question in the exam. Just the use cases of the elastic load balancers. And something that you have to bear in mind is that when you see millions of requests per second, that will be a network load balancer. Okay, so be careful with that. Operates on the left or that will be a network load balancer. Layer 7 application load balancer. Both layer 7 and layer 4 is a classic load balancer. So classic load balancer operates at both the application and the transport layers. Okay, so it can work with both, right? It can load balancing of HTTP, HTTPS, and TCP and SSL traffic. So basically, this guy is a combination of these guys when it comes to the balance that it can load and also the layers they operate at. Okay? And it basically does the load balancing across multiple EC2 instances. It doesn't have the capabilities of the network and the application load balancer. It's a classic one, right? It's a classic one. It's the previous generation one. And AWS decided to split this guy into two and have a more heavy duty elastic load balancers. Okay. So elastic load balancers, they accept incoming traffic from clients, right? From clients, and routes requests to its registered targets, right? The registered targets. Sorry, sometimes my slides move because my cursor, I'm trying to move the cursor here, and this is very sensitive, okay? It's a little annoying for me, but I have to deal with it. You see, it happened again, right? And also in one or more availability zones. So we have availability zone A here, and we have availability zone B here, okay? So it's working with both availability zones because it has cross-zone load balancing enabled. Okay. So you configure your load balancer to accept incoming traffic by specifying one or more listeners. So you have two listeners here, and they're going to listen in port using port 80, right? Port 80, which is very common, which is the web browsing port, right? 80 or 443, depending if it is HTTP or HTTPS, right? So a listener is a process that checks for connection requests. It is configured with a protocol and a port number for connections from clients to the load balancer. Similarly, it is configured with a protocol and port number for connection from the load balancer to the targets. Okay, to the targets. You can also configure your load balancer to perform health checks. So you're going to have health checks. It's going to be checking for the health of the targets. This one is not healthy, so traffic is not routed to this one anymore, right? These three are healthy, so it's going to be, sending the traffic to every single target, right? When the load balancer detects an unhealthy target, well, it will stop sending traffic there, right? And it will resume routing traffic to the target when it detects that the target is healthy again. So there's a key difference in how the load balancer types are configured. With the application load balancer and network load balancers, you register the targets in target groups and route the traffic to the target groups. With classic load balancers, you register the instances with the load balancer. Okay, so you have to create a target group with the application load balancer and the network load balancer. With the classic load balancer, just register the instances directly to the load balancer. And I'm going to show you that later, guys. So there are many reasons why you should use elastic load balancer. Okay. One of them is to achieve available or high availability and better fault tolerance, right, for your application. So elastic load balancing balances traffic across healthy targets in multiple availability zones. If one or more of your targets in a single availability zone are unhealthy, elastic load balancer will route the traffic to healthy targets in other availability zones. After the targets return to a healthy state, then the load balancer will resume automatically the traffic to those targets. So with the containers, automatically load balancer your containerized applications with enhanced container support for elastic load balancing. You can now load balancing across multiple ports on the same EC2 instances. And you can also take advantage of deep integration with Amazon Elastic Container Service, ECS, which provides a fully managed container offering. You only need to register a service with a load balancer, and Amazon ECS transparently manages the registration and deregistration of Docker containers. So the load balancer automatically detects the port and dynamically reconfigures itself. Okay. Automatically scale your application, right? Your applications. Elastic Load Balancing works with Amazon CloudWatch and Amazon EC2 auto scaling to help you scale your application to the demands of your customers. Amazon CloudWatch alarms can trigger auto scaling for your EC2 instances fleet when the latency of any one of your instances exceeds a pre-configured threshold. And I think that I showed that before. Okay. So Amazon EC2 auto scaling then provisions new instances, and your application will be ready to serve the next customer request. Then the load balancer will register the EC2 instance and direct traffic to it as needed. Okay. Now, virtual private cloud. You can use Elastic Load Balancing to create a public entry point into your VPC or to route request traffic between tiers of your application within your VPC. You can assign security groups to your load balancers to control which ports are open to a list of allowed sources. Now, because Elastic Load Balancing works with your VPC, all your existing network access control lists, NACLs, are routing tables continue to provide additional network controls. And when you create a load balancer in your VPC, you can specify whether the load balancer is public, which is by default, or internal. You can have internal load balancing or internet-facing load balancing. If you select internal, you do not need to have an internal gateway, an internet gateway, to reach the load balancer. And the private IP addresses of your load balancer will be used in the load balancer's domain name system DNS record. Now, for hybrid environments, right? Elastic Load Balancing enables you to load balance across AWS and on-premises resources by using the same load balancer. For example, if you must distribute the application traffic across both AWS and on-premises resources, you can register all the resources to the same target group and associate the target group with the load balancer. Alternatively, you can use DNS-based weighted load balancing across AWS and on-premises resources by using two load balancers, with one load balancer for AWS and the other load balancer for on-premises resources. You can also use hybrid load balancing to benefit separate applications where one application is in a VPC and the other application is in on-premise location. You put the VPC targets in one target group and the on-premises targets in another target group, and they use context-based routing to route traffic to each target group. And last but not least, you invoke Lambda functions over HTTP or HTTPS. Now, Elastic Load Balancing supports invoking Lambda functions to serve HTTP or HTTPS requests. This enables users to access serverless applications from any HTTP client, including web browsers. You can register Lambda functions as targets and use the support for content-based routing rules in application load balancers to route requests to different Lambda functions. And you can use an application load balancer as a common HTTP endpoint for applications that use servers and serverless computing. You can build an entire website by using Lambda functions or combine EC2 instances, containers, on-premise servers, and Lambda functions to build applications. As you can see, load balancing is super important when it comes to the high availability of your application. Okay.
Is this triggered by traffic, latency? How? how does it? Kind of-
What is traffic?
No, I'm just curious, like if it's going to trigger, is it that all of a sudden you get incoming traffic that then allows you to expand your EC2, or does it see latency in it? How does load balancing
Okay, it has health checks, right?
help?
And it will check if the instance is healthy. If the instance is not healthy, it will start routing the traffic to a different instance, not that one anymore. Now, it's going to be in conjunction with auto scale, right? Auto scaling is going to be, either scaling out or scaling in, and they're going to be working in conjunction. Okay. You're going to be working in conjunction. I'm going to give you a demonstration later of how this works. Okay. So you must support content traffic to a containerized application. What load balancer do you think that we can use here?
Application.
That's the answer. Okay. You have extremely spiky and unpredictable TCP traffic. TCP. Layer 4.
Network.
Network load balancer. Very good. You need simple load balancing with multiple protocols.
Classic.
You need to support a static or elastic IP address or an IP target outside of VPC.
Is that network?
Good. You need a load balancer that can handle millions of requests per second.
Network.
Network.
Piece of cake now. You must support HTTPS request. Piece of cake. Application load balancer. Very good. Very good. So now we have CloudWatch metrics, right? And used to verify that the system is performing as expected and creates an alarm to initiate an action if a metric goes outside an acceptable range. So Elastic Load Balancing publishes data points to Amazon CloudWatch for your load balancers and your targets. Okay, so you can, with CloudWatch, you can retrieve statistics about those data points as an order set of time series data known as metrics. So you can use metrics to verify that your system is performing as expected. Right? For example, you can create a CloudWatch alarm to monitor a specific metric and initiate an action. For example, you can say, just give me some metrics about the CPU usage, right? If it is greater than 80%, just initiate an action, scale out, or do something about it, or send me a notification, right? If that metric goes outside the acceptable range, right? You also have the access logs, and that's what I told you guys before, that the load balancer has access logs, right? And you can use these access logs to capture detailed information about the requests that were made to your Elastic Load Balancer and store them as log files in where? What is the best place to store log files?
S3 buckets.
S3 buckets. So you can use these access logs to analyze traffic patterns and to troubleshoot issues with your targets and backend applications. Also, you have AWS CloudTrail logs. So you can use the AWS CloudTrail to capture detailed information about the calls that were made to the Elastic Load Balancing application programming interface, the API, right? And store the log files where? What do I store the log files?
S3 buckets.
In an S3 bucket. So you can use these CloudTrail logs to determine who made the call, what calls were made, and when the call was made, and the source IP address of where the call came from, and so on and so forth. So you can do all that with load balancer and monitoring. Okay. So takeaway of this section is Elastic Load Balancing distributes incoming traffic or network traffic across multiple targets in one or more availability zones. Elastic load balancing supports 3 types of load balancers: application, network, and classic load balancer. Elastic load balancing offers instance health checks and security and monitoring. Right? Let's talk about CloudWatch. Okay. Now, to use AWS efficiently, you need insight into AWS resources. For example, you might want to know when you should launch more EC2 instances. If your application performance or availability is being affected by a lack of sufficient capacity, how much of your infrastructure is actually being used? So how do you capture this information? Well, with CloudWatch, that's the answer, right? So we have Amazon CloudWatch here, okay? Well, Amazon CloudWatch is a monitoring and observability service that is built for DevOps engineers, developers, site reliability engineers, and IT managers. Okay? It monitors your AWS resources and the applications that you run on AWS in real time. So you can use CloudWatch to collect and track metrics, which are variables that you can measure for your resources and applications. You can create an alarm to monitor any Amazon CloudWatch metric in your account and use the alarm to automatically send a notification to an Amazon Simple Notification Service, Amazon SNS, and you know that, right? Topic, and perform an Amazon EC2 auto scaling or Amazon EC2 action. For example, you can create alarms of the CPU utilization of an EC2 instance, elastic load balancing request latency, Amazon DynamoDB table throughput, Amazon Simple Queue service, queue length, or even the changes or the charges of your AWS bill. So you can also create alarms on custom metrics that are specific to your custom applications or infrastructures. So you can use alarms for anything, right? You can also use Amazon CloudWatch events. Right now it's called Event Bridge, right? To define rules that match incoming events or changes in your AWS environment and route them to targets for processing. So targets can include Amazon EC2 instances, Amazon AWS Lambda functions, Kinesis streams, Amazon ECS tasks, step functions, state machines, Amazon SNS topics, Amazon SQS queues, and built-in targets. So many kinds of targets, right? So CloudWatch events becomes aware of operational changes as they occur. They respond to these operational changes and takes corrective action as necessary by sending messages to respond to the environment, activating functions, making changes, and capturing state information. With CloudWatch, you gain system-wide visibility into resource utilization, application performance, and operational health. There's no upfront commitment or minimum fee for CloudWatch. You simply pay for what you use, and you're charged at the end of the month for what you use. Okay? So that's roughly Amazon CloudWatch.
Does CloudWatch have a dashboard?
It does. It does have a dashboard. By the way, it's you can create one, and it's universal, so you can see all the regions resources in different region in one spot. It's universal. So you create a CloudWatch, for example, in Ohio, right? And then if you switch to North Virginia, you see the same dashboard. If you change to Tokyo, you still see the same dashboard. It's universal. Okay, so you can have in one spot different widgets, and with those widgets you can have CPU utilization. You can have concurrent connections in the database, for example. You can have all the widgets that you want, any type you want, with the metric that you are measuring, right? And no matter what region you are, you will be able to see the same dashboard in CloudWatch.
That's cool.
Now, every single service has a section for monitoring, and I'll show you later when I already deleted the EC2 instance, but when you create an EC2 instance, there are different tabs like description, like monitoring, like storage, and the monitor section, you can see the same image that you can have in CloudWatch, you can see it in EC2 instances. Okay, it's like a reflection. The reflection of that section of the EC2 instance, the monitoring section, is going to be reflected in CloudWatch because it's CloudWatch itself, right? But not only EC2 instance, DynamoDB have monitoring as well integrated. Another one, I think that Lambda functions, they have also that. So, but the dashboard I was talking about was the dashboard that you can create yourself, right? And later I will show you, okay? So you create an alarm based on static threshold, anomaly detection, metric math expression, right? Now, when you create an alarm based on a static threshold, you choose a CloudWatch metric for the alarm to watch and the threshold for that metric. So the alarm goes to alarm state, and when the metric breaches the threshold for a specific number of evaluation periods. So for an alarm based on a static threshold, you must specify the namespace, which is the one that contains the CloudWatch metric that you want to, for example, AWS EC2, right? You want to work on the EC2 instance. The metric, which is the variable you want to measure, for example, CPU utilization, right? The statistic, a statistic can be an average, sum, a minimum, a maximum, sample count, or a predefined percentile, or a custom percentile, okay? The period, okay, is the evaluation period for the alarm. When the alarm is evaluated, each period is aggregated into one data point. Okay? The conditions, when you specify the condition for a static threshold, you specify whenever the metric is greater or equal, lower or equal, or lower than the threshold value. And you also specify the threshold value. Additional configuration, for example, this includes the number of data points within the evaluation period that must be breached to trigger the alarm, and how CloudWatch should treat missing data when it evaluates the alarm. Because sometimes the data is missing. There's no enough data to trigger an alarm. Right? And finally, the action. You can choose to send a notification to an Amazon SNS topic, or to perform an Amazon EC2 auto-scaling action, or an Amazon EC2 action. So depending on what you really want to do, okay? Now, for this activity, see if you can identify which are correct CloudWatch alarms. For the ones that are incorrect, see if you can identify the error, okay? So let's see the first one. So let's see if it is correct or incorrect. Just try to, if you don't know, guys, try to guess. If average CPU utilization is greater than 60% for 5 minutes, do you think that's correct?
No, because it's average. It's a value.
It's what?
Why is average? I don't know.
No, that's correct.
Ah, okay.
So CPU utilization is a metric in CloudWatch for EC2 instances, right? If that utilization is greater than 60%, if you take a look at this, you see here, that number here, this number here is 100%. You put a number here, but this is evaluating percent, right? So you're saying here, if the CPU utilization is greater than 100%, then do an action for 5 minutes straight, right? The other one, if the number of simultaneous connections is 10 for 1 minute, what do you think?
Correcto.
Correct. If the maximum bucket size in bytes is around 3 for 1 day.
Let me say it's around. Have to be a number because it's the maximum.
Incorrect. Around is not a threshold option. You must specify a threshold of greater than, greater or equal to, less or equal to, or less than. Okay? So you don't say around. That doesn't make sense. The other one, if the number of healthy hosts is less than 5 for 10 minutes, what do you think? Well, let me tell you something. Number of healthy hosts is a metric for load balancing.
Correct.
Remember that the metrics will vary depending on the service, right? If the volume of read operations is greater than 1,000 for 10 seconds.
Also correct.
Incorrect, because you must specify statistic. For example, average volume. Okay? So that's the ways for you guys to have an idea how metrics work. Okay? And you want to trigger an action if that becomes true, right? So when you see around here, that doesn't make sense. It's not around, it has to be specific, right? And also it's the average volume. So you have to do statistics here. Any question, guys? A lot of information, right?
It's a free service, right? CloudWatch, or is there?
It's a free service by default, but it has a paid version. The free, which comes with your account, it will deliver metrics every 5 minutes. But the one that is paid, it delivers metrics every minute, right? The basic monitoring and the detailed monitoring. Those are the ways that you refer to them as, right? One is free, but it's very limited. It doesn't have all the metrics, all the capabilities, right? And you have the paid version, which has more metrics, right? So Amazon CloudWatch helps you monitor your AWS resources and the applications that you run on AWS in real time. CloudWatch enables you to collect and track standard and custom metrics, set alarms to automatically send notifications to SNS topics, or perform Amazon EC2 auto scaling or Amazon EC2 actions. Define rules that match changes in your AWS environment and route these events to targets for processing. Okay. Let's talk about Amazon EC2 auto scaling now. Okay, why is scaling important? Well, it's very important, right? And what is scaling? Scaling is the ability to increase or decrease the compute capacity of your applications. Right? Now, to understand why scaling is important, you have to consider this example of a workload that has varying resource requirements. In this example, the most resource capacity is required Wednesday, right? And the least resource capacity is required on Sunday. One option is to allocate more than enough capacity so you can always meet your highest demand. In this case, Wednesday. However, this situation means that you are running resources that will be underutilized most days of the week. Right? With this option, your costs are not optimized. Another option is to allocate less capacity to reduce costs. This situation means that you are under capacity on certain days. So if you don't solve your capacity problem, your application could underperform or potentially even become unavailable to your users. Okay? So as you can see here, green is use capacity, demand, and gray is provision capacity. Okay? There's a lot of unbalance in this situation here, right? Now, in the cloud, because computing power is a programmatic resource, you can take a flexible approach to scaling. So Amazon EC2 Auto Scaling is an AWS service that helps you maintain application availability and enables you to automatically add or remove EC2 instances according to conditions you defined. Remember the alarm from CloudWatch? Okay, you define that. So you can use the fleet management feature of EC2 Auto Scaling to maintain the health and the availability of your fleet. And when it says fleet, it refers to a group of instances. Okay. Now, Amazon EC2 Auto Scaling provides several ways to adjust scaling to best meet the needs of your applications. You can add or remove EC2 instances manually, on a schedule, in response to changing demands, or in combination with auto scaling for predictive scaling. Okay? So dynamic scaling and predictive scaling can be used together to scale much faster. Okay? So this is the weekly traffic at the retail company, Amazon.com. Okay? This is a typical traffic, weekly traffic of Amazon, right? You see how stable it is, you know. I mean, it's the same thing. The pattern repeats every day, right? So automatic scaling is useful for dynamic, on-demand scaling. Amazon.com experiences a seasonal peak in traffic in November, on Black Friday and Cyber Monday, which are days at the end of November when the US retailers hold major sales. If Amazon provisions a fixed capacity to accommodate the highest use, 70%, 76% of the resources are idle for most of the year. Capacity scaling is necessary to support the fluctuating demands for service. Without scaling, the servers could crash due to saturation, and the business will lose customer confidence, right? So the challenge here is to efficiently guess the unknown quantity of how much compute capacity you need. Okay? So you're using 24%, but 76% is not utilized, right? That's not good. That's not good. Now, another scaling group is a collection of EC2 instances that are treated as a logical grouping for the purposes of automatic scaling and management. Okay? The size of a scaling group could depend on the number of instances you set as the desired capacity. So you have a desired capacity, right? You can adjust its size to meet demand, either manually or by using automatic scaling. You can specify the minimum number of instances in each auto scaling group. And Amazon EC2 auto scaling is designed to prevent your group from going below this size. You can specify the maximum number of instances in each auto scaling group, and Amazon EC2 auto scaling group is designed to prevent your group from going above this size. If you specify the desired capacity, either when you create the group or at any time afterwards, Amazon EC2 auto scaling is designed to adjust the size of your group to it has the specified number of instances. If you specify scaling policies, Then auto-scaling can launch or terminate instances as demand on your application increases or decreases. For example, this auto-scaling group has a minimum size of 1 instance, a desired capacity of 2 instances, and a maximum size of 4 instances. The scaling policies that you define adjust the number of instances within your minimum and maximum number of instances based on the criteria that you specify. And we can see it better here, right? So this is scaling out versus scaling in. With auto-scaling, launching instances is referred to as scaling out, and terminating instances is referred to as scaling in. So in other words, scaling out is increasing the number of instances. Scaling in is just reducing the number of instances. Okay? So you're gonna have a base configuration, which is a launch configuration that you have to create for the auto-scaling group to use and create the instances. You have 2 instances here. You start with 2 instances here, right? This is the desired capacity, right? And then you may need to change that, and it will scale out, launch an instance, right? And here it scales in, it just terminates 1 instance. It depends on the actions that you decide. You define that using a scaling policy. Okay. Now, to launch an EC2 instance, another scaling group uses a launch configuration. The launch configuration contains the AMI, the Amazon Machine Image, the instance type, the role, the security groups, and the EBS volume. So this is like the skeleton of your instances, right? Then the auto-scaling group will use that configuration, right? And launch the instances either with the option of using a load balancer if you want, but you have to put your resources in a VPC and subnet. Remember, when you create an instance, you have to select the VPC and the subnet. You have to do the same, because when auto-scaling scales out, it's going to create an instance, where actually, when you create the auto-scaling group, immediately, it just meets the desired capacity, and it will create a number of EC2 instances based on the desired capacity. And it's going to put those instances in a VPC, the VPC that you specify, right? So what we're going to use? We're going to use an AMI to create the instance, the launch configuration, where you're going to put it, where you're going to put it in a VPC, right? Inside a subnet, right? And then when it's going to happen, well, you need to maintain the current number, right? And it's going to do the health checks. If one instance, let's say that the desired capacity is 3 and one instance goes unhealthy, well, you have 2, right? You need to have 3 because that's the desired capacity. So it's going to create another instance to keep that capacity, the 3. There will be a manual scaling, the minimum, the maximum desired capacity, right? The schedule scaling, schedule action. Let's say that every day at 5 p.m. you want to scale in, mean reduce the number of EC2 instances, right? And every day at 8 a.m. you want to scale out, create the instance again, right? Well, so it's gonna be great, right? Also, dynamic policies. You can have scaling policies. If CPU is greater than 60%, then please create an instance. Right? And you can have dynamic on-demand scaling, right? This is a more advanced way to create your resources. It will enable you to define parameters that control the scaling process. For example, you have a web application that currently runs on 2 instances, and you want the CPU utilization of the auto-scaling group to stay close to 50%. when the load on the application changes. So this option is useful for scaling in response to changing conditions. When you don't know when those conditions will change, then you can use dynamic scaling because it gives you the extra capacity to handle traffic spikes without maintaining an excessive amount of idle resources. So you can configure your auto scaling group to scale automatically to meet this need. The scaling policy type determines how the scaling action is performed. When you use this, you can use Amazon EC2 auto scaling group with Amazon CloudWatch to trigger their scaling policy in response to the alarm. Right. Now, predictive scaling, you can use Amazon auto scaling with AWS auto scaling to implement, because you have EC2 auto scaling and AWS auto scaling, two different auto scalings. When you use them both, you can implement predictive scaling, where your capacity scales based on predicted demand. Predictive scaling uses data that is collected from your actual EC2 usage, and the data is further informed by billions of data points that are drawn from our own observations. So AWS then uses well-trained machine learning models to predict your expected traffic and EC2 usage, including daily and weekly patterns. The model needs at least 1 day of historical data to start making predictions. So the data is going to be there usually after 24 hours. Right? And then it creates a forecast for the next 48 hours. The prediction process produces a scaling plan that can drive one or more groups of automatically scaled EC2 instances. That's the predictive scaling that uses machine learning behind the scene.
Repeat that, please. The start.
Which one?
Could you repeat where you said that when you have two scaling policies?
Yes, there's one scaling policies that is used, for example, by AWS DynamoDB, right? The one that says EC2 auto scaling is only for EC2, right? So auto scaling monitors your applications and automatically adjust capacity to maintain steady predictive performance at the lowest possible cost. Using AWS auto scaling, you can set up scaling for multiple resources across multiple services and minutes. You see here that we haven't talked about EC2 instances, right? It's just auto scaling as a service, right? But you can have auto scaling for EC2 instances. You can have auto scaling for ECS. You can have auto scaling for DynamoDB, and you can have auto scaling for Aurora, right? So there's one auto scaling that is the general one, right? And they're auto scaling specifically for these services, right? So you can use both this guy, right, and the specific one for EC2 to have these predictive policies, right? I don't know if you understand what I'm saying. Auto scaling is just a service, right? Like Amazon S3, like DynamoDB, it's a service, right? But they work with specific services like EC2, ECS, DynamoDB, Amazon Aurora, right? They can scale automatically. These services can scale automatically, and they use auto scaling for that, right? You want to increment the number of containers, then you use auto scaling, right? The number of containers that work with EC2 instances, right? They're called containerized applications. Right? So you can auto scale those applications using auto scaling, right? You want to increment the number of EC2 instances, you use auto scaling, right? You want to increment the number of you want to scale your database in DynamoDB, you use auto scaling, and you want to increment the replicas of Aurora, you use auto-scaling. Is that correct? Do you understand, Sean?
Yes.
Okay. It's just a service, but we call it auto-scaling Amazon EC2, right? Or Amazon EC2 auto-scaling is because it is the one that we use for EC2 instances, right? But it doesn't mean that the only one that there is the EC2 instance. There's also auto-scaling for the other 3 services that you see here. Okay. Okay, so implemented dynamic scaling. Okay, so, well, one common way or one common configuration for implementing dynamic scaling is to create a CloudWatch alarm that is based on performance information from your EC2 instances or load balancer, right? When a performance threshold is reached, what happens? A CloudWatch alarm triggers an automatic scaling event that either scales out or scales in this case, EC2 instances in the auto-scaling group, right? And when you say auto-scaling group, that's EC2 instances, okay? Now, to understand how it works, consider this example, right? You create an Amazon CloudWatch alarm to monitor the CPU, right? Right here. The CPU utilization across your fleet of EC2 instances. And you run automatic scaling, okay? Automatic scaling policies if the CPU utilization across the fleet goes above 60%, right? For 5 minutes straight. Now, Amazon EC2 auto-scaling is instantiate a new EC2 instance into your auto-scaling group based on the launch configuration that you create, just like we did here. A launch configuration that we created. Okay. Now, after the new instance is added, Amazon EC2 auto-scaling makes a call to Elastic Load Balancer to register the new EC2 instance in the auto-scaling group. Okay. Elastic Load Balancing then performs the required health checks and starts distributing the traffic to that instance. It will route the traffic between EC2 instances and then feeds the metrics to Amazon CloudWatch. Okay. It will constantly send the metrics to CloudWatch, like the number of healthy targets, the number of unhealthy targets, things like that. So, Amazon CloudWatch, Amazon EC2 auto-scaling, Elastic Load Balancing, they work well individually. However, together, they become invincible. They work together in teams, very, very well. Okay. Right. They're super powerful when they work together. They increase the control and flexibility over how your application handles customer demand when they work in teams. So far, you learned about auto-scaling EC2 instances with Amazon EC2 auto-scaling, right? So you learned about scaling EC2 instances with Amazon EC2 auto-scaling. You also learn that you can use Amazon EC2 auto-scaling with AWS auto-scaling to perform predictive scaling. Okay? Now, AWS auto-scaling is a separate service. It's why, like I said before, it's a separate service, right, that monitors your applications. It automatically adjusts capacity to maintain steady, predictable performance at the lowest possible cost. And the service provides a simple, powerful interface that enables you to build scaling plans for resources, and including the ones that I mentioned before: EC2, ECS, DynamoDB, and Aurora replicas. Okay, don't forget auto-scaling works with EC2, ECS, DynamoDB, Aurora, EC2, ECS, DynamoDB, Aurora, EC2, ECS, DynamoDB, Aurora. So if you're using Amazon EC2 auto scaling to dynamically scale your EC2 instances, you can now use it with AWS auto scaling to accomplish predictive scaling, like we mentioned before, right? And you can use them in combination to scale additional resources for other AWS services. Well, here we have the takeaways of this section. Scaling enables you to respond quickly to changes in resource needs. Amazon EC2 auto scaling maintains applications availability by automatically adding or removing EC2 instances. An auto scaling group is a collection of EC2 instances. A launch configuration is an instance configuration template. Dynamic scaling uses Amazon EC2 auto scaling, CloudWatch, and Elastic load balancing. And AWS auto scaling is a separate service from Amazon EC2 auto scaling. Okay. Guys, there's a lab for this section. It's there on Canvas. Right? Scale and load balance your architecture. I strongly recommend doing the lab because that's super important to understand how this works. Okay. So the scenario of this lab, right? You will use elastic load balancing with Amazon EC2 auto scaling to load balance and scale your infrastructure. And you will start with the given infrastructure. So CloudFormation will create all this for you in the background. Okay? When your lab starts being created, CloudFormation that template is going to be run, and then it's going to create all of this. It's going to create 2 availability zones in a region. It's going to create 4 subnets for you, 2 privates and 2 publics. It's going to create a NAT gateway. It's going to create an RDS database, which is the primary, right? It's going to create a DB, the secondary one. It's going to create another server, a server in the second availability zone, right? And of course, it's going to create all that, inside the VPC. That's going to be the initial setup of your lab. Okay. The task, you have to create an Amazon machine image, right? Just one moment here. Oh, sorry. One moment, guys. Okay, so it's going to create an Amazon machine image from a running state, from another instance. It's going to create an application load balancer, create a launch configuration and an auto scaling group, automatically scale new instances with a private subnet, create Amazon CloudWatch alarm, and monitor performance of your infrastructure. That's going to happen. Now, this is going to be the final product. Okay, it's going to have all the setup before. It's going to create an instance here where there was nothing here. There was no, there was no instance here. A new instance is going to show here, right? It's going to show another instance here. It's going to have this elastic load balancer, right? Sending traffic to this particular web instances here, right? Web instances. And that's going to be the final product. Okay. Of course, there's going to be an auto scaling group, scaling these applications here. Okay. Any questions, guys? Long morning, eh?
Yes, I have a question. So With regards to DynamoDB, is there auto scaling for DynamoDB?
Yes.
And does it scale horizontally or vertically?
Horizontally. Horizontally.
Okay. So
Yeah.
let me just be
Go ahead.
clear about some other things. So DynamoDB is also based on EC2, right?
No, DynamoDB is a database.
Yes, but I mean on the back end.
Yeah, of course. Is it too
Based
easy?
on EC2, right?
Is it too easy? There are servers. They work with databases, right? Right. There can be a connection between them. So you want to work with a web server probably in the front end, a web server, right? You may have an application server in the middle tier, and you can have a DynamoDB in the back end, right? You can work that way. So the web server gets the request, the application tier has the business logic, and the database has the persistent data, right? Is that what you're asking?
No, not really.
Okay, go ahead.
Because I've been doing the practice exams, and there are a couple of the services that I keep on getting confused with.
Which one?
Elastic Cache, especially.
Elastic Cache is a layer that you can put next to an RDS, right? To cache the most accessed information and to lower the latency, right? You cache the information there. That's for RDS, right? That's for RDS. For DynamoDB is DynamoDB Accelerator. That's another service. So every service has its own way of caching, right? And we're talking about databases, right? So RDS will use Elastic Cache. DynamoDB uses DynamoDB Accelerator, okay? Also known as DAX, right? You see, Amazon DynamoDB Accelerator is a fully managed, highly available in-memory cache for Amazon DynamoDB that delivers up to 10 times performance improvement from milliseconds to microseconds, even at millions of requests per second. Okay, so DynamoDB uses DynamoDB Accelerator for caching. Elastic Cache, okay, Elastic Cache is allows you to simply set up, run, and scale popular open source compatible in-memory data store in the cloud, build data intensive apps, or boost the performance of your existing databases by retrieving data from high throughput and low latency in-memory data store. Remember that cache is in memory, right? It's in memory. Amazon Elastic Cache is a popular choice for real-time use like cases like caching, session stores, gaming, geospatial services, real-time analytics, and queuing. RDS, MongoDB, and Cassandra. But don't forget that MongoDB and Cassandra, they're not supported by RDS. Remember that's it's only Aurora, MySQL Server, MariaDB, Postgres, Oracle, and Microsoft SQL Server. Okay, those are the only ones that are supported. It does support NoSQL, like MongoDB and Cassandra, but not DynamoDB. DynamoDB is also NoSQL, but it's the AWS solution, right? This is our third-party solutions, right? So basically, when it comes to AWS, you can cache on our DS database, right? I don't know if that answers your question.
No, but I'll figure it out.
You said that Elastic Cache was showing up in your databases, right? In your exams, right? So
Yeah.
you were asking what Elastic Cache is? But
No,
this,
I was asking more about when you have to scale DynamoDB, if it scales horizontally or vertically, and if it uses EC2 on the back end to do that.
oh, well, there's servers, but not EC2. There's servers. And remember, EC2 are virtual servers, right? When DynamoDB scales, or DynamoDB is running, there are servers, physical servers in the AWS data centers. DynamoDB is serverless. DynamoDB is serverless. So it doesn't, you don't have to worry about any server. RDS is not serverless, right? There's no EC2 instances in the background when it comes to DynamoDB. There's no EC2 instances when it comes to RDS. There's a server, but it's not an EC2 instance. You can have a database in an EC2 instance. And I think I did an example here in class, right? When we saw databases.
Yes, you did.
You can host a database in an EC2 instance, but that's something that you choose to do. It's not something that happens automatically. You choose to do it. So there are certain advantages. You have more control, right? On that, you can choose the operating system. You can choose the engine that you're going to use, MySQL, Oracle. You can choose that. With RDS, you still choose the engine, right? But you don't manage anything else. It's a managed service, right? There's several ways that you can host a database. You can have it on premises, which is your problem, basically, right? AWS has nothing to do with it. You can have it on an EC2 instance. You're going to have a lot of overhead because it's infrastructure as a service. So you have a lot of control and you have to do a lot of installation. It's not a managed service. Or you can have a database using RDS, right? And you only have to worry about the optimization of your data. That's it, nothing else, right? Behind the scenes, even behind an EC2 instance, there is a physical server, of course, in a data center in AWS. There's always servers in the back end, but I don't have to deal with them, right? That's AWS. A database, there has to be a server somewhere, right? For the database to run, there has to be a server, right? True or false? Is it true or false? Sean?
Yes, it's true.
So the server is a physical server for DynamoDB. It's not an EC2 instance. EC2 instances for other services, like, for example, when you deploy an application using Elastic Beanstalk, it will create an EC2 instance for you because your application will need a server, all right? So DynamoDB is a key value and document database that can support tables of virtually any size with horizontal scaling. See there? You see? So in the same table, you can have any size. You can add as many items you want, right? As many items as you want, right? And it will scale horizontally automatically, right? And you can have any amount of items no matter what. Okay? So it does horizontal scaling. Our RDS take care of the scaling of your, or you can scale horizontally for ready, heavy applications. This scales horizontally too. You can create real replicas. See the image here? When you create real replicas, you are scaling horizontally. As you can see here, we're not scaling like this, we're scaling horizontally. So basically, we are incrementing the number of replicas, right? That's RDS. So DynamoDB doesn't have to create all the tables. The same table horizontally scales, right? And it's incredible how fast this can be. It's less than 10 milliseconds, right? But if you have DAX, DynamoDB Accelerator, you can go from milliseconds to microseconds. That's awesome, right? So I don't know if I answered your question. I wish I did. Okay. So, summary, module summary. In this module, you learn how to indicate how to distribute traffic across Amazon Elastic Compute Cloud instances using Elastic Load Balancing. Identify how Amazon CloudWatch enables you to monitor AWS resources and applications in real time, and explain how Amazon EC2 autoscaling launches and releases servers in response to workload changes. Also, perform scaling and load balancing tasks to improve an architecture. Don't forget to do this, guys, in your Canvas platform. And there's a question for you guys. Which service would you use to send alerts based on Amazon CloudWatch alarms?
A. I see.
Hey,
So what is the key word?
send alerts.
And the answer is, just like you said, A is the answer. Right? And thank you. Great. We are officially